Well, good morning, good afternoon, or good evening, everyone. Thank you for joining us today. My name is Dan Schmidt, and I am the Marketing Director and also one of the product managers here at Standard Imaging. Our talk today is entitled Daily QA Before Your First Cup of Coffee, and I've already finished mine, so I guess we're good. We'll be reviewing today the benefits and the use of the QA BeamChecker Plus, along with the MIMI, Phantom, and HexaCheck. I plan to show you how these devices can add simple, fast, and reliable QA to your daily LINAC startup routine. Just a few housekeeping items here today. I did want to share, as you heard, perhaps, that this webinar is being recorded and will be available for viewing on our website shortly. The attendees are in listen-only mode. You are encouraged, however, to type any questions that you might have into the question box on your webinar console. And if there is time available at the end here, we will answer those if possible. Otherwise, I'll certainly follow up via email to any outstanding questions that we didn't have a chance to get to. If you're not aware, Standard Imaging is based in Middleton, Wisconsin. We were founded about 31 years ago in 1989, and we do design and manufacture a full suite of QA products for radiation therapy, and we are pleased to partner with you now and in the future. And that's why we like to say it's your time, be precise. So let's begin by talking about the daily LINAC QA objectives that you might have for your system. You certainly want to verify the beam output, the flatness and symmetry, that those are remaining constant for all the energies on your machine. And you want to know, based on a specific time frame, that those have not changed. So you're going to set a time point and say, this is day one, and I want to know what changes might have occurred every day subsequent to that. You might also want to verify the constancy of your wedge beams, whether those be physical or electronic dynamic wedge. Verify the consistency of other items like your MLCs, along with gantry rotation. And you certainly want some convenient reporting and trending of that data so that you can easily validate that that has occurred. And then this is the point that we like to focus on, sort of like my piano teacher told me a long, long time ago, trying to play a very difficult piece. Play this is meant to be played as fast as possible, but not faster. And the point is certainly that there's a balance, that you want to do a good job in testing your LINAC QA, but you obviously can't spend all day long testing it. You want to do it as quickly as possible, but as correctly as possible in the time, and use your time as efficiently as possible. And today I hope to be able to show you how the QA BeamChecker and the MIMI can help you do just that. So in the US, at least, we would be talking for daily LINAC QA TG142, a double APM task group 142. And the following procedures there, the QA BeamChecker is very good at: testing X-ray output constancy, electron output constancy, laser localization, at your ISO center, verifying that your ODI is set correctly and that then the collimator size at that distance is identified correctly. And you may also, I believe, recommended that you check at least perhaps one angle for your wedge during a morning checkout. I do want to point out that all of the data from the QA BeamChecker Plus, and this applies as well to the MIMI and HexaCheck that we'll look at later, can be pulled into or has templates for our QA Pilot software, which is an integrated platform that allows you to centralize and manage all of your QA performance data. We have various webinars on those over on our website, as well as coming up here very shortly. So we certainly invite you to look into those if you're interested in QA Pilot to learn more about that software. So let's look at the basic specifications then of the QA BeamChecker Plus. And here it is in all its glory. Some of the specifics: ionization chamber based array. So there are 8 parallel plate ionization chambers arranged in a cross pattern in here. Of those, 5 actually do the measurement of the radiation, and 3 of them, well, they all measure radiation. but 5 do the measurement of the flatness, symmetry, and constancy, and the remaining 3 are used with different filters in front of them to identify the energy, and I'll talk about exactly what that is a little bit later. When you're measuring photons, there's a photon and an electron side of the device. We have 3.5 centimeters of water equivalent buildup on the photon side and 1.5 centimeters on the electron side. So in order to do a measurement, you simply flip the device over, and this is done specifically to get measurements closer to Dmax and to be more stable and more correct. The system can measure constancy, flatness, and symmetry for photon energies all the way down to cobalt up to 25 MeV, and on the electron side it's 6 MeV up to 25 MeV. You can track and store individual radiation measurements for up to 9 different treatment rooms on the device. It will just simply set up and say RM1, RM2, and balance those so that you can very easily switch between rooms. We find that most folks do not do that many, of course, perhaps 2 to 3, but it's nice to know that you have that capability. You can very easily trend and graph the results and generate simple reports for those with the software, and I'll show you that as we move forward. And then as you see down at the bottom here, there's a power data cradle for easy charging of this device. It is battery powered when it comes off of the cradle, typically used in that fashion. And the cradle then can also be used to communicate to the database that it resides on a single computer. So we believe that really with this system, the ease of use is the key to its design. And a couple of the features that make that the case, this patented wire-free mode. So as I talked before about the energy filters that are on the device, essentially this is what is identifying the energy that you're shooting it with, and we use that as the key to remember the flatness, symmetry, and constancy that the device has seen for that energy. That allows us then to have a software-free solution. We do not need to be running any software because all those keys that we call them energy scores are stored specifically on the device so that it can easily identify it. So this allows the therapist to perform those morning LINAC QA checks without any software, no computer to run, makes it quick and easy. The interface, as I'll show you in a little bit, gives you a very quick pass-fail indicator for each of the beam parameters. If things are good, which they normally are, you move forward quite quickly, and this makes your morning checkouts very fast. If you do want additional data, you can run the device in a connected mode, and I'll show you some pictures of that in just a minute. The other feature of this automatic energy detection, the energy scores that I talked about, allows you the ability to deliver any of the energies in any order. So on the photon side, you can deliver your 6x or your 10x. Either way, doesn't matter. On the electron side, take your pick, start at 21 and move down to 6, or go the other direction. And this allows you to reduce errors in delivery where you may have mistaken or you incorrectly followed some sort of parameter. The device automatically detects what that energy is and then knows and compares to the stored values of what the flatness, symmetry, and constancy should be for that energy. So a couple of unique features then on this system. We've got an integrated buildup, as I mentioned before, and again, this is done because it makes the measurements performed near or beyond Dmax and allowing you to be up on that curve so that you're not on the steep part of the curve, you're closer to the flat part of the depth dose curve, and you get a much more repeatable measurement in that fashion. It is also high dose rate compatible as well. You can take it up to 24 MU per minute. We allow a lot of flexible QA here. We provide a mode for checking rapid arc or VMAT delivery. There's a dynamic mode on here that you can deliver actual treatment beams if you desire to do that. We've got ability to do tomotherapy, dynamic and static beams, as well as the laser tests, and then the wedge beams, as I had already mentioned. In addition, we, of course, do automatic temperature and pressure compensation with this system. And we have a real-time real-time clock, which puts a date and time stamp on every single data point that is taken, and that's all stored along with every measurement. And then another unique thing is the physics mode, where you can actually use this to do some simple testing if you'd like. You can export the data, and it essentially just acts as 5 ionization chambers that you can control, start and stop, save the data, export the data in a 20 by 20 field. So let's look then a little bit about how exactly you use the system so that you have a better understanding of how the workflow goes. So the initial setup here, you first have to train the system to tell it what the beams look like, so that when you first get this, and you do this at the very beginning of when you got the system, or perhaps when you had some major surgery or something that happened to your LINAC and you need to re-baseline things. So there is a standard serial connection that's going to run from the device sitting on the treatment couch back to your computer, the host computer where the software is running. Or we also have, as shown on the right here, a Bluetooth option where this Bluetooth transceiver pendant is now the mating one of it is sitting somewhere by the opening in the vault. You simply then line this system up to the correct height. So using your ODI on this nice white surface with the black interrupted lines. And by the way, we find that to be far and away over the years has been the simplest, fastest way to do alignment of light fields with a white field with black lines with some interruptions. Allows you to very quickly and easily line up your field. So first of all, you'd set the surface of the device to 100 cm, turn on your collimator with a 20 by 20 field, and there's very precise markings here which indicate if anything is slightly off. So you're testing all those systems at the same time that you're setting it up. You do the alignment. There's also laser marks available in the back and the front here that help you do the alignments and see that your lasers are all lined up correctly. So that would be the first initial setup. And then you go to the software and define those action levels. So here's where you're training the system with what each beam looks like. So here's a glimpse into the software. This is a few tabs in where you have defined and said, I'm connected to the unit up here, ready to go. This is about to be irradiated with a 6 MV photon beam. I've got a 20 by 20 field. I'm going to deliver 100 MU at 400 MU per minute. The date and time is automatically stamped in there for you. You're allowed to select action levels as well at this time. And those can be set actually individually per each of these different channels. So for the flatness, the symmetries, or the constancy can all have different action levels set on them if you'd like to do that. But typically action level 1 is something where we've got a slight drift going on, and I should alert my physicist and let them know that something is going on, but I can probably still continue to treat. People typically use 2 to 3% for that action level 1 from a shift from the baseline value. Action level 2 is where there's really something serious that I need to have my physicist look at this before I begin treating patients, and there typically people put 4 to 5% on, say. So once I have this set up and I'm all ready to go, I would simply turn the beam on, and the device automatically will identify that the beam has turned on, and this will go to collecting. And so we would deliver that normal beam, and once we see that the value is good, we simply say save, and then that value is stored both in the database and on the device itself. So for the wire-free measurements, it doesn't need to be connected to the software to know what all those parameters are. So we do this for every beam that we're going to be irradiating and testing in the morning, and then we simply place the device back on the power data cradle for the next day. And most people typically include this place this power data cradle in the control room, but certainly you can put it anywhere that you would like. Generally, it's recommended to keep things out of the bunker if you can help it, just for good practices. And of course, this is, as you see, this is plugged into the wall here, so this is recharging the battery while it is not being used. So now you're all set for your daily QA. And the next day, then, it's very simple that the morning procedure, the therapists walk in the wire-free mode, and they simply pull the device off of the power data cradle. I'll let my screen catch up here a little bit. So they remove the device from the power data cradle, and they simply walk into the bunker and place the unit onto the table, onto the treatment couch, turn it on, and do the alignment. So again, this would be setting the table height to the correct distance, setting the collimators to 20 by 20 field, aligning that light field, checking that the laser lines are now also coincident. And then on the front of the device here, you can see I've turned it on and it says RDY, ready. And on the front of the face of the label, it says photon. So I know that I'm on the photon side. There's also a button here. Later, when I'm going to do my electrons and I flip it over, there is a mode setting where I simply press the mode button and it'll flip it to electrons, and then this will flip over. And of course, this is on the other side. I'll point that out when we get to the image there of that. So I'm all ready to go and take my measurements. I walk out of the room. I've not run any software. I'm all set to go. And I then look at the device, the front face of the device with the camera in the treatment, the console room. And I can see the front face of the device. It says that it's all set and ready to go. And I just begin irradiating now with any beam that I have a baseline for. When the device begins a measurement and identifies that radiation is present, you see some spinning wheels on the front to indicate that, yep, it's taking a measurement. And when it is done, then it will automatically detect and report to you on the front face what energy it has measured. So in this case, we're showing 06X. We've seen a 6 MV photon beam. And now as soon as that irradiation is completed, the system will go and look in the baseline and say, I know what a 6 MV beam should be like. And it will compare what it has stored, what you baselined on it, to what it just measured today. Is the constancy, is the symmetries, and the flatness within those action level parameters. If they are acceptable, you simply get a red light here, a green light, and this display goes back to ready, and it says RDY. It stores all those parameters, and it's set for the next energy. And that usually is just a couple of seconds when you finish the beam and it's all done, and you get a very quick indication that beam is good to go for today, and I'm ready for the next one. So what happens in the rare case when a beam is out of tolerance? And in that case, then you do get, again, sorry, I'm letting my screen catch up here. When a beam is out of tolerance, then on the front face of the device, you do get some additional information of what that out of tolerance is. So on the front face here, we're seeing CST for a constancy error, TSM for transverse symmetry, ASM for axial, FLT for flatness, and there's a few other screens as well that show you additional diagnostic information. You'll also get an auditory alarm, and the green lights on the front face turn to red and flash, and they beep at different rates for action level 1 or action level 2. And you do need to walk into the bunker and press the reset button in order to save and store, to acknowledge that an error has occurred. But all those values are stored on the device, and then it again goes back to say ready, and it saves all that information, and you have access to it later. Now, if I'm going to do my electrons, I simply walk into the vault, and I need to put my electron cone on anyway in most cases. And here you can see where I've flipped the device over. Now the RDY is on the right side of the screen here. I've pressed the mode button, and so the display has inverted, and of course it says electrons on the label here, so there's no confusion. We find that people are very quick at doing this. The therapists, of course, are extremely good at their job, and typically it's 10 to 15 seconds at most to reline up this light field, and I think that's a small penalty to pay for getting different thicknesses of material in place here for a much better measurement on that electron side, a more appropriate amount of buildup and a healthy amount of signal, which you wouldn't perhaps get through 3.5 centimeters of water with a variety of electron beams. So good metrology is the key, and a very, very small time penalty to realign that device. When all of my beams have been irradiated, then I simply take the device and I set it back onto the cradle in the console room, and I'm all done. Now, typically, how would you then download the data? Most of our customers will generally, about every once a week, will go on, the physicist perhaps will go on and download that data. And so when you start up the software, you'll see on the data tab, that this new data is available, that there's data to download. This is green. I press on it and it indicates all the values that it's got available, and it downloads those. And then you're allowed to see those and interact with them. You can look at it with a chart view or a table view. You pick which energy you want to see, and you can also pick the date, time here. We're showing about a month's worth of data, and this is pretty typical. You can see that the green ranges is below action level 1. The yellow ranges are between action level 1 and 2, and the red would be outside action level 2. You can turn, by clicking these buttons, you can turn any of these on or off to see any individual parameter better. And you can print and export that data as well. And it prints everything in a .csv file. Here's an example of what the reports would look like when you press that button. You get a nice output of every single value that has been obtained during that time frame that you pick. Or a graph of that information, and of course it allows you a spot where you can sign off on that chart as well. If you are connected to the system with a PC, you do get just a little bit more information. In that case, you don't need to walk into the room. In the case of an error, a beam error, you can clear that from the software, and you get an actual readout of the differences. And so here we would be showing a difference in our transverse symmetry that exceeded that action level 2, and so we've got a red light here. So we use the simple red, yellow, green lights to indicate when you are within those ranges of dead on action level 1 or action level 2. There's some additional capabilities for the system as well. If you want to measure, as I said, your enhanced dynamic wedges, or for rapid arc or elective VMAT, you can develop actual treatment plans and deliver them to these ionization chambers and then come back and measure them. And all of these things can be set directly from the front face, again, by choosing the plan. There's some simple codes there, and you do not in any case need to fire up the software to take initial morning measurements. There is also an available gantry mount should you wish to take rotational measurements. We've got an additional leveling plate and a system in here to allow you to take measurements for the HiArt systems for H-series, or Radixact for the Accuray tomotherapy systems, as well as the device can be used for CyberKnife, Accuray CyberKnife. We've got an accessory called a cutting board, which simply gives you some fiducials and allows the BeamChecker to be placed very precisely. The fiducials in the cutting board then allow you to use your positioning X-rays to align the device correctly to measure the CyberKnife system. So a quick summary then of the QA BeamChecker Plus, that hopefully I have been able to convince you that this is a fast, reliable system for your daily LINAC QA. Because of that innovative wire-free mode, you do not need to run any software, and this is the reason that the therapists just love this system. We've developed this for high quality design and for very stable readings, and that integrated buildup is one of the reasons, along with the high precision electronics that Standard Imaging is known for. We're known for our ionization chambers, our electrometers, and the ability to measure small signals very, very well, very, very reliably, and the system really combines the best of both worlds there. That automatic energy detection means that you don't have to worry about what order that you're irradiating the system in. And because of the robustness of this design, it does come with a 2-year warranty. Now we've got over 1,500 of these systems in the field since 2006, and we have continuously worked on improving their radiation capabilities, the withstanding radiation damage. And it is true, this is a tough environment for any kind of electronics to work in, so these systems do get beat up a bit, but we continually work very hard to shield electronics that could be susceptible to issues, and there are often upgrades available to older systems as needed when those become available. We do provide intuitive trending and reporting of the data, and the system can do a rotational dynamic QA capabilities as well for tomotherapy, CyberKnife, RapidArc, or VMAT, and it has an available gantry mount. So that is a bit about the QA BeamChecker. Hopefully much of what you were hoping to get out of our talk today. I'd like to turn then to your daily image guidance, radiation therapy QA, and talk a little bit about the Mimi Phantom along with the HexaCheck. First of all, I would like to thank Dr. Alonso Gutierrez from Baptist Health Mammy Cancer Institute for some of the following information that I'm presenting to you today based on some of his experiences with the system. What are you going to do when you want your morning image guided radiation therapy QA? What are your objectives? And really, you obviously want to ensure that the radiation and mechanical isocenters of your systems coincide, that those coordinates for planar MV and KV imaging for imaging and treatment coincide at the 4 cardinal angles. If you've got for cone beam CTs, you again want to know that the imaging and treatment coordinates are coinciding, and you want to do some positioning, repositioning tests to verify that your couch is working correctly. If you've got a 3D couch, if you happen to have a 6 degree of freedom, and I'll call them a 6 DOF or a 3 DOF couch here. If you have a 6 DOF couch, we realize that accuracy is extremely important. There have been lots of studies, and Miami Cancer Institute has been one that has led the way in some of this, indicating that if you are doing things where you have a single isocenter with multiple targets with your 6 DOF couch, you should certainly be doing a daily image guide check on your couch, especially if you're doing things like head and neck or spine or SPRT with that system. It's very important. And then just, of course, the existing recommendations for doing that would be for AAPM task group 142 for regular linear accelerators, TG 148 for helical tomotherapy, and 224 for proton therapy QA. So you may have some additional things that you'd wish your system would standardize across, depending on perhaps the size of your facility or the capabilities that you have. You've certainly got some different imaging systems, right? You have KV planar systems, KV cone beam. If you've got a tomotherapy system, you'll be doing MVCT. You may also have different treatment units or using them in different ways. So you may be doing a variety of IMRT or VMAT treatments. You may have a proton therapy system, or you may have some specific machines that are used primarily for SBRT. And then, as I mentioned, you may have a 3D, a 3 DOF couch or a 6 DOF couch. So all those different modalities would lead you to say, I would like to really have one device that would allow me to do all of my morning IGRT QA. And today I would present to you then the Mimi Phantom that can do that, the multiple imaging modality isocentricity Phantom. And let's look just a little bit deeper at what the Mimi Phantom can provide to you. I'll go into a few more of the details here. A very robust design. We have machined this from a very highly precise plastic. This is a 14 centimeter cube on each side with extremely high tolerances on the design. We provide a variety of known offset positions on each face so that for laser line alignment as well as measuring displacements are very easy to set up, and there are fiducials at each of these intersections. The engineering that went into identifying the imaging modalities and having very, very few artifacts was extensive. So whether you're shooting KV, MV planar, CBCT and MBCT, or even doing surface imaging with this system, we have designed it so that you get minimal artifacts on any of those systems. You can use this, the Mimi Phantom, on any and all couch tops, and it provides, because of the unique design, which I'll show you in just a second, a very simple, fast, and consistent way to do your auto registrations for the volumetric imaging. And here, if I take the covers off a little bit and make it a little bit more transparent, you can see that internally we've got 5 bone equivalent rods that are in a unique position, in a crossed position here, that intersect at 90-degree angles when they're measured from any face. So any DRR or a 2D projected image is going to give you a cross picture, which will allow you to very easily do a 2D match on any slice from your imaging. As I had mentioned before, on every face we have a 1 millimeter ball that indicates where all the center is or where the alignment lines are. Again, marked very nicely and easily. Positional indicators machined into the system so that they show up very easily, as well as a central ball. And I talked about the fast verification of the isocenter positioning, and I'll show you an image of that next. At the very center of the ball, we do have a 6.4 millimeter ceramic BB. And again, this one was chosen very carefully so that at KV or MB images, you do not get artifacts that cause concern. And finally, the offset crosshairs in each face at known positions to allow you to do that offset test. Here's the image then of a comparison for a 2D match. That's coming up in just 1 second. There we go. To show you what that would look like to allow a very quick and simple 2D match or 3D match for your auto registration systems. For your system, again, any slice will show this pattern because of the unique design. Now, if you do have a 6 degree of freedom couch, then you certainly would like to add the HexaCheck. The HexaCheck system is designed specifically for the Mimi Phantom, and it rests in a cradle down here. And this is a true 3-axis gimbal system. And what this means is that as the system rotates in either direction for roll, pitch, or yaw, the isocenter remains at the dead center. And that is not the case if you were to use something like a simple wedge underneath your Phantom to do these testings at an offset. You'd be shifting your true isocenter. So this 3-axis gimbal allows isocenter to always remain the same no matter where your setup is. There's a pin for each of those 3 settings that pulls out and allows you to set in 3 distinct positions. So a plus 2.5 degrees, a 0 position, or a minus 2.5 degrees. And these are, again, highly precise machined locks. 2.5 degrees was chosen as a fairly typical value for what you might see as an error, a correction error on your patients, and it allows you to set any of those to do a comparison once your table identifies that and then corrects. Again, the high precision of the system, what we have seen is repeatabilities of plus or minus 0.05 degrees and an accuracy of plus or minus 0.1 degree. The couch lock portion down here, the base of this mates into a couch lock so that you can fit it onto any of your couches, again with a high degree of precision and repeatability, and that has proven to be very stable over time. Dr. Gutierrez has done long-term studies indicating that yes, this is very simple for folks to set up and can do it very repeatably over time. It is compatible, as I mentioned, with the Varian Perfect Pitch, the Electa Hexapod, the Leone robotic couch for protons, along with BrainLab Exact and the Accuray Robo couch. Now, rather than going into too much detail, as I see we've pretty much run out of time, there is a tutorial video both on our website, and I've listed it here, and there is a link that would come along with it. It's on our YouTube channel as well as on our website. That essentially just allows you to go through these steps and to see, and I'm sure that you all understand, you know, exactly the way that you'd use this to do an initial 0 setup with the system, do a CT with that, save that as the reference image, induce any number of adjustments that you wish to do, image those, tell your couch, your 6-degree freedom couch, to correct those for 0, and compare then back to what the actual couch moved to what you know it to be based on the changes that you've induced in the system because of the HexaCheck. So I would point you to that for additional information if necessary. And that ends the majority of my discussion today. I would invite you to go to our website if you would like to see more on these webinars. They are available at the link here, standardimaging.com/webinars. And that's where the recording of this webinar will end up. We've also got much more information just on our website as well on these systems and the rest of our standard imaging products. And you can also contact us via sales@standardimaging.com or to me directly at dschmidt@standardimaging.com. And I thank you for your time. I apologize for going just a little bit over. I can certainly hang out here for a while in case anyone has any questions that they wish to throw into the question box. All right, so I'm not seeing any questions at this point, so I thank you again for your time and look forward to serving you in the future. Have a good day, everyone.